Electric cars changed transportation forever. So why can't we just put batteries in a plane and call it a day? The answer isn't technology, it's physics. And solving it might change aviation forever. Welcome back. We've covered how planes fly, how engines work, how safety improves. Today, we're tackling aviation's biggest challenge, emissions. By the end of this video, you'll understand why jet fuel is hard to replace, and what the realistic path to zero-emission flight looks like. Let's start with the core problem, energy density. Jet fuel contains about 12,000 watt-hours per kilogram. A modern lithium-ion battery? About 250, that's 48 times less energy per kilogram. For a 737 carrying 20 tons of fuel, you'd need nearly 1,000 tons of batteries. It won't fly. And it's not just weight. Batteries don't get lighter as you use them. Jet fuel burns off, making the plane lighter and more efficient. Batteries stay heavy the whole trip. That's why electric cars work for daily commutes, but not for crossing oceans. Current battery technology limits electric aircraft to short hops, maybe 200 to 400 miles. That's great for regional flights or air taxis. But for the 95% of emissions from long-haul flights, batteries alone aren't the answer. So what is? Enter Sustainable Aviation Fuel, or SAF. SAF is made from renewable sources, used cooking oil, agricultural waste, even captured carbon and green hydrogen. It can reduce life cycle emissions by up to 80%. Here's the key. SAF is drop-in compatible. No engine modifications. No new infrastructure. Airlines are already using it. The challenge isn't technology, it's scale and cost. Right now, SAF makes up less than 0.2% of global fuel. To meet 2050 targets, we need to scale production by 500 times. But it's the most realistic path to decarbonizing existing fleets. SAF also reduces contrail formation, those white trails that trap heat. Some studies suggest contrails cause as much warming as aviation CO2. For the long term, two technologies offer true zero-emission flight, hydrogen and electric. But they solve different problems. Hydrogen has incredible energy by weight 3 times jet fuel, but it's bulky. Storing it requires cryogenic tanks at minus 253 degrees Celsius. That means redesigning the entire aircraft. Airbus's ZEROe concepts show what's possible. Blended wing bodies with hydrogen tanks in the fuselage. Electric aircraft are happening now for short ranges. eVTOL air taxis? Those are electric by design. The technology works. Hybrid electric might be the bridge. A small turbine generates electricity to charge batteries. You get fuel range with electric efficiency. So what's the realistic path? It's not one technology, it's a portfolio. SAF this decade. Hydrogen by the 2040s, electric for regional routes. And here's the good news, you won't notice the difference. Same cabin, same comfort, same safety. The revolution happens behind the scenes. Decarbonizing aviation isn't about giving up flight, it's about reimagining it. The technology exists. The will is growing. If this changed how you see the future of flight, hit subscribe. Drop a comment. Which solution excites you most? Thanks for watching.